As of Kotlin 1.9, the standard library includes a stable timing API. So let's jump in and see what it's all about. The most common thing we'll need to do with Kotlin's timing API is to simply measure how long some chunk of code takes. So let's start with that. The classic way to measure time is to record the time before the operation, then record the time again after the operation, and subtract the two to get the difference. In Kotlin, you only have to do this once or twice before you start asking yourself, why wouldn't I just wrap this code with a function that takes a lambda? Then I could measure time everywhere. Well, everything in this function has to do with measuring time, except for this line, which is the workload. So we can just make a parameter for that, which will have a function type, and invoke that parameter. And then we can just wrap any code with our stopwatch function, and we'll get the output in the console. Well, there's no need to write this function ourselves because Kotlin's standard library gives us a couple of functions that work roughly like this. But instead of printing the duration to the console, like we're doing here, it returns it from the function. One such function's name is measureTime. So let's remove our stopwatch function and replace it with measureTime. Give it the old import. And then be sure to assign the result to a variable. And for now, let's just print out the duration to the console. When we run this, we see how long the operation took here, and in this case, it's printing it out in milliseconds. But if it takes long enough, you can see it prints it out in seconds. Now this approach works well when the operation is just fire and forget, but sometimes that long-running operation returns a value that you want to hold on to for later. For example, in this code, the calculate function returns a random hexadecimal string on each call. If we want to store that string in a variable, we could just create a variable for it up here, assign it inside this block, and print it out below. But that's just not the level of elegance that I want for my Kotlin code. So instead, we can use a related function called measureTimedValue. It's not measureTimeValue, it's measureTimedValue, so make sure you put the letter D in there or you're not going to find the import. This function works just like measureTime, but it returns an object that contains both the duration and the result from the code block. And if you prefer, you can use a destructuring assignment here to separate those two into different variables in one shot. And there we go, that feels a lot more like Kotlin to me. Now, when we were measuring time manually at the beginning of this video, the start time and end time variables were in nanoseconds, but we wanted our duration variable to be in milliseconds, so we had to divide the difference by 1 million. When the types you're working with are just simple long integers, it leaves room for mistakes. It would have been easy to divide by the wrong number here. One of the great things about measureTime and measureTimedValue is that they don't return simple long integers. They return an object that has a type called duration. And this duration class can handle all of those time unit conversions for you. So far, we've only printed out these duration objects, but there's a lot more that we can do with them. Now, if you're like Mr. Grumpy Recalcitrant Man, you might be saying, Dave, why are you going to use classes for checking the fastness when they're so expensive to instantiate? Well, you're right. On the JVM, it's typically more expensive to instantiate a class than to just use a simple number type, because an object goes on the heap instead of just hanging out on the stack. And when we're measuring performance, we don't want to accidentally affect performance. Thankfully, duration is a value class, so it doesn't go on the heap. In other words, it looks like a class to us developers, but to the JVM, it's basically just a long. Now, before we go looking at all that the duration class offers, let's look at a few more ways that we can create duration objects. As we saw, we can get a duration from measureTime and measureTimedValue, but we can also easily create a duration by hand, using extension properties on integers, longs, and doubles. So for example, to create a duration of 2.5 seconds, we could just write 2500.milliseconds like this, and import the property. Now in this example, it might actually be more natural to express this in seconds. So instead, we can write this with a double and use the property seconds instead of milliseconds. Now this duration class is useful not just for measuring time, but also for specifying it. For example, inside a coroutine, you might want to delay for some period of time. But the question is, does this delay function take its argument in seconds, or milliseconds, or nanoseconds? Well, now it doesn't matter, because it also accepts a duration object, so you can specify it in whatever time unit you want, from nanoseconds up to days. Hopefully you won't need to delay for days. And we can also use arithmetic operators on durations. So for example, instead of 6.25 seconds, we could create a duration from 6 seconds plus 250 milliseconds, using a plus operator like this. Subtraction between two durations is also supported, and you can also multiply by a scalar and divide by either a scalar value or a duration. Alright, now that we can get a duration object, what can we do with it? Well, to start with, we can get the duration in a variety of time units, anything from nanoseconds to days. So for example, if you want the duration in nanoseconds, just get duration.inWhole nanoseconds. Or of course for milliseconds, it's in whole milliseconds. As the word whole conveys, these properties truncate the fractional part. So if the duration were 2.5 seconds, then duration.inWhole seconds would return only 2, and duration.inWhole minutes would simply return 0. So when it comes to these whole properties, the greater precision you need, the finer the unit of time you should use. So that's one way to get duration values. But what can we do if we want that fractional part included? Well, one option is to use a function called toDouble. The toDouble function requires us to pass in the duration unit that we want. So if we want 2.5 seconds expressed in minutes, we could call duration.toDouble and then duration unit.minutes. And when we run this, we see that 2.5 seconds is roughly 0.0416 of a minute. Just keep in mind that if the duration is long enough, it might not actually fit in a double. As you can guess, toDouble hangs out with a few buddies named toInt and toLong, but they pretty much just do what those whole properties do anyway. Now, each of these whole properties and conversion functions produces a number that represents as much of the entire duration as it can. So if you've got a duration of, say, 2 minutes and 53 seconds, in-whole minutes would return 2, truncating the 53. In-whole seconds would not return only the 53 from here. It'll return all 173 seconds from the entire duration. Expressing this duration as 173 seconds is helpful in a lot of cases, but it's not always entirely natural for humans to think this way. For example, if you were told that you've still got 534,600 seconds to request a refund for a purchase, you probably wouldn't have much of a sense for how long that actually is. The number is big enough, and the time unit is fine enough that it's just kind of hard to fathom. On the other hand, if you were told that you've still got 6 days, 4 hours, and 30 minutes to request a refund, well, that's much easier to understand. So sometimes, instead of expressing the entire duration in a single time unit, it's just more helpful to express it with multiple time units that all add up to the total duration. To break down a duration into its component time units like this, you can call a function named toComponents, which takes a lambda. So for example, here I'm splitting the duration into its pieces. So to recap, the whole properties and conversion functions give you the entire duration in any single time unit. toComponents gives you the duration in multiple time units that all add up to the entire duration. Now what about those times when you want to send a duration to a server or store it in a database? Well, one option is to just pick a time unit and store it as a number using that time unit. But that opens up the risk of misinterpretation, where you might store it as milliseconds and somebody who comes along later retrieves it thinking that it's in seconds. Thankfully, there are standards for serializing durations. You might be familiar with ISO 8601, which is a standard for representing dates and times as strings. But you might not know that that also includes a standard for representing durations and intervals. Getting a duration in ISO 8601 format is as easy as calling duration.toIsoString. When we run this, we get a string that looks like this. So that's 148 hours and 30 minutes. Now, what about parsing an isostring back into a duration? Well, that's also very easy. We just call duration.parseIsoString and pass it the string that we want to parse. Now keep in mind that this function will throw an illegal argument exception if that string isn't a valid isostring. If you don't like exceptions, you can use parse isostring or null instead, which, as you can guess, will return a null when the string isn't valid. Well, now that we know lots of cool things we can do with duration objects, let's get back to measuring time. We've already seen how simple it is to use measureTime and measureTimeValue. Now these two functions are great when the code you want to measure can be wrapped within a single function. But sometimes things aren't so clean in real life. For example, when you're creating a plugin for a framework, you might have a hook for the beginning of an operation and another for the end of an operation. Since these are split across two different functions, there's just no way to wrap the operation. So in other words, we can't just say measure time in here because the long-running operation won't happen until after this function returns. And we can't say measure time in here because the operation already ran before this function is called. For cases like these, it might be tempting to go back to system.nanotime directly, checking the start time before the operation, getting the end time after the operation, and then doing the math that we did before. Instead, Kotlin's timing API gives us a way to mark different points in time, and then later we can compare them. Instead of checking system.nanotime, we can get a time mark. And here's how we do that. Instead of getting system.nanotime, we call markNow, and we do the same thing afterward. So when we call markNow, we get a time mark. And when we subtract them, we get a duration. And then we don't have to do this math ourselves. This, of course, is a lot like the manual time measurement that we did at the beginning of this video. The big benefit here is that instead of using long integers, we're using time marks and durations. It's also easy to imagine how time marks can be helpful for cases where you simply want to mark your progress along some sequence of steps. So for example, here we've got a sequence of startup steps for an imaginary system, and we mark the time at each step along the way. And then when it's done, we can print out how long each step took, as well as how long the entire sequence took. Let's give this a run. So here we can see we've got how long it took at each step. So we've got service initialized in about 1 second, resources allocated in 1.4, and splines reticulated in 560 milliseconds. And then the total time is just shy of 3 seconds. So for those cases when measureTime or measureTimeValue won't cut it, time marks are here for you. Now, in order to mark a time, we have to use a particular time source. In this video, it hasn't been very obvious because I tucked away the time source in the imports section up here. But you can see we're using TimeSource.monotonic.markNow. TimeSource is an interface, so you can implement it on your own if you want. Most of the time, TimeSource.monotonic is all you need. And by the way, if you're wondering what a monotonic clock is or why you might want to use one, you can check out the previous video where I explain the differences between a wall clock and a monotonic clock. Under the hood, the monotonic time source will use the appropriate clock. So for example, if you're targeting the JVM, it's going to use system.nanotime. When you're targeting browser JavaScript, it'll default to performance.now. And when targeting Node.js, it'll use process.hrtime. There aren't too many occasions where you're going to need to create your own implementation of time source, but one where you might want to consider it for now is if you're an Android developer and you want to use a monotonic clock that continues ticking even when the device is in deep sleep, then right now you'll need to create your own one based on systemclock.elapsedRealtime or systemclock.elapsedRealtimeNanos. I expect Google's probably going to end up adding this kind of an object to one of the KTX libraries, but we'll see. As you can see, it's actually very simple to create your own time source by using the abstract long time source as a superclass. Short of implementing time source yourself, Monotonic is the only real option that the standard library gives you. However, It does also provide a time source that's useful in tests. For example, here's a stopwatch plugin that's similar to the one that we saw before, but instead of statically referencing a time source, this one accepts a time source as a constructor parameter, and instead of printing out the duration, it stores it in a property. We can use the TestTimeSource class to write some simple test code for this plugin. All we got to do is instantiate the TestTimeSource, then pass it into the plugin's constructor, and then between the before and after hooks, we can advance the clock by any duration that we want, just by using the plus assign operator like we're doing here. And finally, we can write an assertion to make sure that the plugin reports the duration that we expected. Naturally, this is useful when you're writing test code where you actually have a chance to advance the time source between the calls to mark now. So in other words, if these two calls to mark now were in the same function, our test code wouldn't have a chance to advance the clock between those calls, so test time source wouldn't be helpful. In cases like that, if you wanted to write tests, you could consider using a mocking framework to create mocks of the time source and time marks, assuming you're targeting a platform that actually supports mocks. With that, we've covered the salient features of Kotlin's newly stable timing API. Drop a comment to let me know what you think about this API, or let me know if you have any questions. Thanks for hanging out with me today, and I'll see you next time.